Willkommen to Uncle Beckman's chemical class. So today we're going to be talking about ionization energy. But first we need to know what it is. So open your little writing books. Here you go. Ionization energy is the energy needed to remove one electron from each atom in 1 mole of gaseous atoms to form 1 mole of gaseous ions. Write that down. Okay, now we move on. So, what determines the ionization energy? Remember, the energy needed to remove one electron. It's to do with the nuclear attraction to the outermost electron, the one being removed. And we abbreviate this to NATO. Nuclear attraction to outermost electron. Yeah? So, when you have an atom, you have an attraction between the negative electron here and the positive nucleus. So, as the energy, the ionization energy is the energy needed to remove the electron, the more attraction there is between these two, the more energy is needed. So, as this attraction increases, the nuclear ionization energy increases as well. You see? And as it decreases, ionization energy decreases too. Stop there. Okay, so now there are 3 factors that influence, that affect NATO. Okay, nuclear attraction to the outermost electron. So, the first factor is the atomic radius. And all this is the distance between, from the nucleus to the outermost electron, okay? Now, if this electron is far away, there is not much electrostatic attraction, so NATO decreases. Therefore, ionization energy also decreases. But if we move this closer, there is more attraction, and so NATO increases. Ionization energy also increases because more energy is needed to remove it. So, factor number 2. This is the nuclear charge. Say you have an electron there and a single proton in the nucleus. This is hydrogen. There's one positive charge here that attracts the electron, but because it's just one, it's not so strong. But if the nuclear charge increases and you get more protons, they pull stronger on the outer electron because of the opposite charge, and so NATO, nuclear attraction to the outermost electron, increases, and so the ionization energy also increases. You get this, yeah? You get it, yeah. So, now we move on to factor 3. Okay? Now, you have your outer electron and your nucleus, which is all positive. But who's to say there's not some other pesky electrons here? Yeah? Now, these electrons here, they are going to block the attraction from this electron to the nucleus. Okay? These ones, oh yeah, they're being attracted, but these, they can't exchange photons so easily. Don't worry about that. All you need to know, these electrons, the electron shielding blocks the attraction between these two, and so the nuclear attraction decreases if you have electron shielding, even more so if you have more electrons, and so as the nuclear shielding increases, NATO decreases, ionization energy also decreases because less energy. Okay, so the video sort of cut out there. Basically, as a summary, the more electron shells you have between the outer electron and the nucleus, the more nuclear shielding you have, the less nuclear attraction there is between the outer electron and the nucleus. Therefore, the lower the ionization energy. Okay. Now, when we look at the periodic table, we will notice that there are some trends for ionization energy as you move around the periodic table. So let's try to explain that. Now, as you go across a period, the nuclear charge, the amount of protons increases. For example, here, from sodium to magnesium, you go from 11 protons to 12 protons. Now this increased nuclear charge means that there's more strong attraction between the outer electron and the nucleus, and so that causes ionization energy to increase. Now, as we go across the period, because there is also more electrons and more protons, the opposite charges attract each other more strongly, and this actually makes the atom smaller. So although you're getting more electrons and more protons, this actually reduces the atomic radius. And so the reduced atomic radius means that there's greater attraction between the outermost electron and the nucleus, and so the ionization energy increases as well as you go across. Now, factor number 3, electron shielding. Both sodium and magnesium and all the others, when they're all in the same groups, they will all have the same amount of electron shells between the outermost electron and the nucleus. Okay? Now, this isn't sodium, forget that, but this is just the principle. And so, the electron shielding is the same, and so the ionization energy for that doesn't change. And so overall, because of these 3 factors, we can say that going across a period from left to right, ionization energy overall increases. Okay? Now, going down, we see that the nuclear charge increases again, increasing ionization energy. The atomic radius increases because although there are more electrons and protons, we've got to remember that we are adding more electron shells between them. And so the more shells you have, the larger the atom is. And so that reduces ionization energy. And also, didn't have to write that out. Also, as you increase the number of shells between the outermost electron or electrons and the nucleus, that also increases the electron shielding. And so that also reduces the ionization energy, because there is reduced attraction between these outer electrons and the nucleus. And so, because of this, we can say that overall, ionization energy decreases going down a period. So it increases going across, it decreases going down. Okay, so now when we talk about ionization energy, it's important to remember we're not only talking about removing one electron or even the outermost electron. We're talking about removing any of them. Okay, and these happen in successive ionizations. So the first ionization, as you can guess, we remove one electron, and this forms a 1 positive ion. Yes? Now we remove the second electron. Okay? And this becomes 2 positive. And we'll get onto this later, but as you carry on removing these, you get the energy, the ionization energy needed to remove them increases as you carry on removing them. And so you can take on off another and another and so on. Okay, stop there. Okay, so here we have the graph that we plot for ionization energy. Okay, the successive ionizations. Here on the y-axis we have the ionization energy, here on the x-axis we have the number of ionizations. And so what that means is that each little mark here is a successive electron that we are removing. So now, initially you will see that between here, the third and the fourth electron, there's a massive gap in the ionization energy. It increases lows. And why that is, you will see here. These are the first 3 electrons you're removing, because they're the outermost electrons. You remove from the outermost ones. And so, bear in mind, there is another electron shell in between them and the nucleus. And so, they don't require as much energy to be taken away. But, when you get to these ones, they have no electron shielding, so their attraction to the nucleus is stronger. And so because of that, they need more energy to be taken away. And that is why we see this here, this increase in the ionization energy. Now you'll notice as well that even when the electrons are in the same shell, when one is removed, the next one still has a slightly higher ionization energy. And all that is because as successive electrons are removed, the nucleus pulls on these remaining ones stronger, okay? They are pulled stronger towards it. And that's it. That's all you need to know. So thank you very much. I hope I've been a good teacher, and auf Wiedersehen.